The second example is another thing that's cyclical. Tides come in and tides go out. So if you're trying to create an equation so that you can figure out and you can predict when the tides are coming in and when the tides are coming out, you need to gather some data, use that data to graph the situation, and then we can use the graph to create our equations. So here we have the highest tides, the Bay of Fundy, and it has a maximum depth of water at 4:30 a.m. 6 hours and 12 minutes later, it has a minimum depth of 2 meters. So we're going to start graphing this. We're going to put the information that we have on here. We're going to put our depth along our y-axis and our time along our x-axis. And we have two pieces of information. We have that at 4:30 a.m. it has a depth of 8 meters. So along here, I'm going to go mark 8. How would you write 4:30 as a time? Because you can't really put that into your calculator with the 2 dots with 4:30. 4.5. You're not going to go 4.3 because 30 minutes is half an hour. So that's not bad, and most people are able to say, yeah, right away I can figure out 4:30. We're going to have a little bit of thinking to do with 10:42. Okay, but at 4:30, 4.5, it's at 8 meters, so I can put a dot there for that. 6 hours and 12 minutes later at 10:42. So 10:42 is going to be about there. What am I going to put as my decimal for 10:42? It's got to be higher than 4.5 because it's more than half an hour. And how did you figure out that you were going to use 0.7? You divided 30 by 5? Okay, and what did that give you? 6. And so how did you get 0.7? That would get you.
42 is 30 and 12, and 12 is 2 sixes, so added the 2.
Oh, I see what you're saying. So you're saying that you added 12 to 30, yeah, and then that is another 0.2.
Yeah.
Okay. Anybody come up with another? Does everybody understand his method? Yes? Anybody have another way that they came about doing that? Did anybody, how many people said, well, 30 out of 60 is 0.5 as their way of doing the 30 minutes? Did anyone do 42 out of 60 to figure out the 42 minutes? Because it is a proportion, just like we've done some proportions before. So if you did 42 out of 60, that reduces to 7 out of 10, and so that'll be 0.7 that way as well. Okay, good. Well, either way that you came up with the 0.7, we now have, at 2 meters, a point here. So we only have 2 points. We have one maximum and the next minimum. And if something is periodic in nature, in other words, if something is cyclical, that's the only 2 points you need to get all the information. Right now it seems really sparse, but you could tell me when the next maximum is. What would I put for the next maximum? Well, it's going to be back at 8. Does that make sense? If it's cyclical, it's going to be back at 8. What's my x value going to be along my x-axis? There's enough information for us to figure that out. I think the y value at 8 is really easy to figure out. If it's going to go back to its maximum at the next point, it's going to be at 8. But what's our x value going to be? 16.9. And how did you come up with that 16.9?
10.7. And then found the difference between it and 4.5.
So you found out that that was 6.2. That's at your 6 hours and 12 minutes. And you added then 6.2 again. Excellent. So now we got another maximum. Now if you drew your graph through this, your sinusoidal curve through this, and drew it cyclical in nature, what would our center line be? Center line would be 5. And if you had to add your period and add these marks in between, if it's 6.2 from 4.5 to 10.7, it would be 3.1 to here and 3.1 to there to get the points where it's on the center line. So creating our equation, and I believe this question, just go forward here, they want one equation in sine and one equation in cosine. To create our equation, well, we have to think about DAB-C and work our way backwards. So the D and the A value, like we did yesterday, those ones you can get almost simultaneously. The D value here is our center line is 5. Can you see that your amplitude is 3? I don't know if that looks like a 3. There we go. Our B value is related to our period. Remember that our B value is 2 pi divided by our period. And so looking at our graph, our period is how long it takes to complete one cycle. I could take this point here, this maximum. How long is it before it gets to the next maximum? Well, we've already looked at that. We said it was 6.2 from the maximum to the minimum and another 6.2 from the minimum to the maximum. So in our question here, our period is 12.4 hours. And so our B value will be 2 pi over 12.4. We need to make one equation in terms of sine and one equation in terms of cosine. And once you have the DAB part, that's going to be the same no matter if you use sine, cosine, negative sine, or negative cosine. So you can start putting those three values in already. So with my sine graph, it would be the A value is 3, sine. B value is 2 pi over 12.4. Bracket x minus something, and then our D value is plus 5. Same thing with my cos graph. A value is 3. My B value is 2 pi over 12.4. And my D value is 5. The only thing I need to figure out for my sine graph and for my cosine graph is where's the starting point. So when looking at the sine graph, we think, where does a sine graph normally start? Well, if it's a positive sine graph starts on the center line going up. So we look at our graph. Do we have any of those points? I have one right here on the center line going up. It looks like I have another one over here on the center line going up. Of the ones that I've labeled there, the second one I actually have a label on it already. So I'm going to use that for my equation number 1. My equation number 1, that would be a shift of 13.8 to the right. And for my coast graph, where does my coast graph start? It starts at a maximum. Well, we have two maximums labeled. I'm going to use this first one here for equation number 2. That's at 4.5, so it would be a shift of 4.5 to the right. So now we have created an equation 1 in terms of sine and 1 in terms of cosine. In part B, it says estimate the depth of the water at 130. Again, you could, like what we did yesterday, figure out how to put this into your calculator, set up your scale so you see the graph exactly. But for this one, we're just going to estimate, where would 1:30 p.m. fit on my time chart here? Because this 4.5 represented 4:30 a.m. Where would 1:30 p.m. be? $13.5. Right? Because noon would be 12, 1 o'clock would be 13, sort of like a 24-hour clock. And if you go up from 13.5 and over, maybe we have an estimate of a depth of 4 meters. So now I would like you to try example 2 on the page. There at the bottom, there's some exercises there. You can just put a line through that. I will also give you the questions that you can do from your textbook right now. So you can do questions 3 through 9 in section 6.7.